Dining philosopher problem is one of the classical problem of semaphore. So let's discuss this. So dining philosopher problem says that there is a dining table, okay, over which five philosophers are sitting: P0, P1, P2, P3, P4. Okay, there are five philosophers, and in the middle of this dining table, there is a bowl of some noodle like stuff, okay, and these philosopher can eat or think, okay, and in between these philosopher there are five fork, or you can say the chopstick. In some books it is written as chopstick. uh, I named these fork as F0, F1, F2, F3, F4. Okay, so this is the situation where five philosophers are sitting on a dining table, and there are five fork, and here some noodle like stuff is there, and the philosopher can eat or think, okay, and each philosopher for eating purpose requires two fork at a time, okay. So whenever the professor want to philosopher sorry whenever the philosopher want to eat, then it require this philosopher will require two fork, okay. So these five philosopher, whenever they want to eat, these philosopher require two fork at a time, okay. And one more condition is this: key, first of all, whenever the process want to eat, it first pick its left fork, then its right fork, okay. So this is the condition, okay. So first philosopher either think or eat, okay. Second, whenever the philosopher require two fork at a time to eat, right, and each philosopher first pick its left fork, or whenever each philosopher will pick its left fork, okay, then it's right one. So this is the condition, right? Now for philosopher, while one, when the philosopher is thinking, do nothing. When the philosopher is in thinking process, then we need not to do anything. And when the professor want to eat, then it will take the fork, ayat fork. Ayat fork means if the philosopher P0 want to eat, so its left fork will be, suppose this is philosopher P0, then its left will be F0, okay, and its right will be F1, okay. So when the philosopher want to eat ayat philosopher, then its ayat fork will be the left fork, okay. So this will be the left fork, right. And for right fork, take fork I plus 1 modulo n. Okay, n is the number of fork. Okay, so this is for right fork. Suppose p0 want to eat, then zeroth yani ki f0 will be the left fork, and 0 plus 1 modulo 5 equal to 1, this will be the right fork. So f0 and f1. Okay, it require f0 and f1 fork at a time. Okay, then if it acquire these two fork, or if it gets these two forks, then it will eat, the philosopher will eat. Then put fork I, in the similar manner as it pick the fork, it will put the fork. Okay, put fork I यानी left fork को put करेगा पहले, and then right fork I plus 1 modulo n. Okay, so this is the situation. We have the five philosopher, and these philosopher will pick the left fork whenever the philosopher want to eat. Okay, so at a time how many philosopher can eat? If p0 acquire these two fork, then p1 cannot eat. Then p2 can eat. If p2 acquire these two fork, then p3 cannot eat, and p4 cannot eat. So at a time only two philosopher can eat, another philosopher will wait. Okay, and suppose, as we have discussed, that each philosopher first pick the left fork. Okay, okay, so if each philosopher, suppose all the philosopher are hungry at a time, and they pick the left fork simultaneously. Okay, each philosopher can pick its left fork first. So suppose p0 picks this f0, then p1 picks this f1, and p2 picks this f2, and each philosopher has picked its left fork at a time. Okay, all the philosophers simultaneously, then there all the philosophers are waiting for their right fork, so there is a problem of deadlock. Okay, so the solution for this dining philosopher problem with the help of semaphore is that we will use here the five semaphore: S0, S1, S2, S3, and S4. Okay, now we are discussing the solution for this dining philosopher problem with the help of the semaphore. Initially, all the semaphore having the value 1, S0 equal to 1. Okay, and we can see in the diagram that for process P0, it requires two semaphore variable, for left fork S0 and for right fork S1. Okay, so here we can write that P0 requires S0 and S1, left and right fork को pick करने के लिए it requires two semaphore. Likewise, P1 requires S1 and S2, left and right, and P2 requires S2 and S3, P3 requires S3 and S4, and P4 requires S4 and S0. Okay, now suppose, so here we can write the code for this first. Okay, so in this uh, here just we can put the wait operation. Okay, this function we can here wait for this left fork, and the philosopher will wait for its right fork, and after eating it will signal its left fork, and it will signal its right fork. Okay, so these two operations, these two wait operation for left fork and wait operation for right fork, the philosopher will invoke, and after um, these two functions or these two wait operation give him the permission to eat, then it will eat, and then it will the signal operation will be used. Okay, so in case of semaphore, here we are using just wait and signal operation. Okay, and now check the scenario that if process P0 want to eat, it will acquire this S0 S1 P1 को क्या जरूरत है S1 S2 की. And the second situation is that if suppose all the philosopher are hungry at the same time and all picks its left fork, suppose P0 picks S0, P1 picks S1, P2 S2, and P3 S3, and P4 S4, it's left fork. Okay, then P0 requires to eat S1. S1 is held by P1. Okay. P1 require S2. S2 is held by P2. P3 require P2 require S3. S3 is held by P3, and P3 requires S4, and S4 is held by this uh, P4 is held by this S4. So here is a chain. Okay, means P0 is waiting for P1's fork, P1 is waiting for P2 fork, and P2 is waiting for P3, and P3 is waiting for P4, and P4 is waiting for P0. So here is a situation of deadlock, and we have to break this chain to come out of this situation, deadlock situation. Okay, so what we will do, we will just interchange the uh, sequence here in P4. Okay, here the P4 first pick its right fork S0, and then it will pick its left fork. Okay, here we have changed the sequence. Okay, so the condition was that the philosopher will pick its left fork first, then right fork. Okay, but here we have changed the situation in the last condition for the last process. For the last process, what we have done that it will first pick its right fork, then its left fork. Okay, so that this process can eat. Once this process can eat, it will release both the fork. Okay, it will free both the fork, and this S4 P3 will get this S4. Okay, then P3 will finish its work. Then it will release or free this S3. Then P2 will eat after getting this S3, and so on. Okay, so this is the solution for this deadlock situation. Okay, this is all about the dynamic philosophy problem.